Thanks everybody for coming. I can see that by the not tons of people, I feel people aren't quite as interested in SLAs as I'd like them to be. I'm Justin Coffey, so some of you know me. And I'm going to talk about SLAs, and SLAs in particular around building out data pipelines that we've done at Criteo, and what I like to call Guerilla SLAs, and how we sort of contributed to changing the culture at Criteo around monitoring the latency in pipelines in particular. So you've already heard a little bit of this. Oh, by the way, this is going to be a little bit of like a conversational kind of thing. I've got one phrase per slide here, so it's meant to just be a fluid thing. There's not a lot of content on here, but yeah. Criteo, what do we do? So historically, we connect advertisers to their users when those users go to other websites, otherwise known as retargeting, right? We collect a bunch of clickstream events on an advertiser's website. We accumulate that stuff. We create a predictive model about it. We know how much advertisers are willing to pay us to get people to go back to their websites and buy stuff, and so we can come up with a approximate value of displaying their ads to those users on other websites, and then we participate in real-time auctions to do that. We also now connect brands to their users on our advertisers' websites. We recently purchased a company called HookLogic, and we call this Criteo Brand Solutions. And the idea is that you type in some sort of a phrase, keyword search on Best Buy's website, and then say Samsung wants to sell you their competitor, the iPhone, an S8 or whatever. You've typed iPhone, and we'll display a Samsung ad to drive you to purchase the Samsung product on Best Buy's website. So that's a new thing. And the thing we like to say as well is that we make publishers' inventories more valuable. So we sort of make it possible to make money on the internet, right? Because we're able to get frequently, not always, right? Sometimes like certain real estate on a publisher's website, like the homepage on the New York Times, is very, very, very expensive. And they're bidding that out at prices that we would never pay. On the other hand, some of those back page spots are otherwise pretty low CPM, and so we're able to actually give them more money than they would otherwise get. So that's how Criteo gives back. We do this across the globe. We're a global company, and we do it billions of times a day. The billions of times per day are the actual ads, the impressions, as David Scheiken referred to earlier. We do, I think we're like 3.5 billion displays per day, and that's off of approximately 200 billion display opportunities. So we make a decision to engage in an auction 200 billion times a day across the globe. We're bare metal. We don't use AWS or Azure or Google. We've got 7 data centers across the globe, so it's a big operation on the data side. So what could go wrong? 7 data centers, 500 billion events coming through those pipes, Kafka distributed mirroring, stuff I don't even understand, all coming into one big honking, now 2 big Hadoop clusters, firing up thousands of jobs, all to make sure that our CEO gets his numbers every day. So it turns out that a lot can go wrong, and so much can go wrong that we stopped calling ourselves any number of names, and we changed our team's name into data reliability engineering. So producing data requires, at this scale, and I think a lot of people undersell the complications at a smaller scale as well, because the complexity of the system can get really, really nasty. You hear all kinds of people talking about their monolithic, big single database instance with a ton of jobs running on that. That can spiderweb out of control as well, right? And so I think just the production of data needs the attention that an SRE-like group would give it, and so hence the name Data Reliability Engineering. So what do we do concretely? We build and operate data pipelines at Criteo. We don't build and operate all of the data pipelines at Criteo, but in terms of from the volume perspective and the variety perspective, we're at about 75% of the production of data, of core data transformations at Criteo. We also ensure that we have a pretty classic stack these days on the cloud native, even though we're not cloud, but referring back to David's talk. Tableau, Hive, Vertica are all owned and operated by us. We've done a fair amount of engineering to make that work at our scale. We have, in Vertica, we have basically a petabyte of data stored across a couple hundred nodes, relatively big nodes. Our largest single Vertica instance has 300 terabytes in it. That we've done twice. We have that replicated twice. Hive, we've done spent a lot of effort making Hive work. Hive is, it's got a lot of peripheral services, and making those things reliable is non-trivial at scale when you've got a high concurrent workload against it. The Hive Metastore is famous for failing miserably and spectacularly. We run that on Mesos now. And Tableau is a beast unto itself. We spent a lot of time ensuring that you can actually have what amounts to a build pipeline, a CI and CD for dashboard development. And that required lots of tooling, lots of effort. Anybody has any questions about that? This talk is not about that stuff. I'd be happy to talk to you guys about that later, our different efforts there. We also write a lot of software, which I've alluded to a little bit, to make that all work well together, usually, right? Software is not, software is fallible. We're certainly not infallible as human beings writing it. We try our best, and it basically works, right? What we don't own is Hadoop itself. There's a different entire team group that's responsible for Hadoop. We call that the Lake team. They own two production clusters today that span about 3,000 nodes. They have another 1,000 nodes sort of on the shelf, and they're going to be building out a third, even the biggest cluster will have built over 2018. That'll be going live. Those clusters are across 2 data centers. They'll remain across 2 data centers. The Kafka team, we call them our Rivers team. They're responsible for getting data into this system that we so lovingly take advantage of. And they own the Kafka hardware. They own the schematization of the data going through Kafka. And they own the loading process of getting Kafka data into Hadoop and into our hands. So this is in the spirit of aspirational engineering. This is sort of our aspirational architecture at the moment. I will go around and point. So this is, as I referred to, the Lake managed Hadoop. So we just don't think about this. We try not to. We own this layer here. All this stuff is all our stuff. So nobody owns Scalding or Spark per se, but we do a lot of engineering around Spark and Scalding to make it work inside of Criteo's architecture and our systems. We do own Vertica. This is a data loading sort of connector that we've written. It's going through many evolutions, and there'll actually be a talk about that in a little bit in greater detail about how we're working to get Parquet as sort of, I want to call it a native format for Vertica. We're not rewriting the internals of Vertica, but how we can get a better binding between HDFS data and Vertica data to make the getting data into Vertica a declarative thing and not this sort of imperative like, some data engineer says now put that into Vertica and here's the pipeline that does it. BossDB will also be touched on a little bit later. BossDB stands for Big Open Source Solution Database. It's sort of Hive next gen, basically. Today, we have a very bimodal performance experience for running ad hoc queries, either using Vertica and your queries on the order of seconds, occasionally minutes, or you're using Hive and your queries on the order of hours, occasionally days, right? And so this is trying to fill the gap. We're looking at stuff like Impala, Presto, Dremio from our fine friend Julian Ledem, even though he's no longer with them. And so that's that roadmap. The query proxy is this idea. So the stuff in blue is under really, really active development. The query proxy is this idea of trying to get in between the queries that are going against initially Vertica so that we can provide some guarantees of query performance by getting in the middle, right? Blacklisting certain plans, blacklisting certain queries. Like I said, we have a replicated 300 terabyte Vertica cluster, do load balancing that's transparent to the end users and things like that. So that's sort of the idea there. If we make this thing sort of work as we hope, then we think that we can sort of extend it across these other SQL engines to provide a single point of entry for SQL analytics at Criteo. So you don't have to think, oh, I'm connecting to Vertica, oh, I'm connecting to BossDB, oh, I'm connecting to Hive. And then we have the data SDK. Guillaume back there is going to be talking about the job scheduler a little bit later today. We also have, like I said, some sort of wrapping software around Scalding and Spark to make that a little bit easier to work with. And this all kind of comes together in sort of a data SDK. I'll be talking about a component in that SDK called SLAB today, and you'll see what that looks like in a bit. Data pipelines, I've just put that all together, but actually it's really awesome that David talked about this idea of certified pipelines, because inside of this mess, there's, across Criteo, I did the measurement, we orchestrate through just our data SDK, we orchestrate something like every day on the order of 30,000 MapReduce stages, all executing in the right order. Within that, there's maybe 30% of that is that we would consider certified. So like part of a core product-driven, R&D produced, closely observed data production pipeline that we sort of guarantee the output on, right? We have on-call for latency in those pipelines. We have all kinds of things, and you'll see some of that stuff. And then these are like just sort of generic client applications, right? So Tableau, you know what that is probably. These are internal projects that you don't care about. And then we're working on some experimental support for Python notebooks as a service, so not just running a little local Docker container. And then we're in discussions with the rest of engineering and about something that we're calling the small app engine, which is really Python CRUD apps on Mesos and Marathon. So that gives you an idea of what we're doing, what it looks like, and where we'd like to go in relatively concise terms, I hope. So, talking about SLAB. So what is SLAB? So first, we're going to do an origin story here that I hope is going to be entertaining. SLAB stands for SLA board. We're not that inventive with names, but it seems to be a good one. And so the origin story. So like I said, we don't just own and operate infrastructure, but we own and operate data pipelines. And those data pipelines have clients, right? People are expecting data to be transformed in a certain way, made available in certain systems under certain time constraints. And frequently across all those 30,000 MapReduce stages, something's going to be late, right? And so this is a very frequent question. Client X asks some engineer, "Hey, where's my data?" Right? And before we had SLAB, this was pretty frequently the response. What data? What are you talking about? Everything's running. It's fine. And then, it's like, that super critical thing that, is needed for the end of the month closing. And by the way, it's the first of the month. Where's the data, right? And then we're like, oh, yeah, that data. Well, it's not our problem. Kafka was down in the EU. Like, we can't produce any data. There's no data coming in, right? So not our problem. And, typically, the response from clients to that is relatively straightforward. It's like that's not my problem, right? That's your problem, and we're like, really? That's our problem? And unfortunately, this would happen, at 3 o'clock in the morning when you're on call, right? So you're bleary-eyed, you get the alert, you log in, and you get really pissed off because you're looking at, you're digging into the system, and you're like, no, seriously, that's not my fault. right? Why am I awake, right? So you get back on Slack and you ping the escalation team like, hey, it's those guys again. Can you go talk to them? Right? Like, oh, really? Okay, I didn't know. Sorry. And you're like, yeah, of course, that's fine. I'm gonna go back to bed. It's like, are you sure? Can't you stay online just in case it's not them? Like, no, I'm sure it's them. Here's the, I'm going back to bed. And so the Kafka thing is just one failure mode, right? In these complex systems, you saw the diagram from David, all these moving components, right? And then of course we have 7 data centers. Hadoop itself, I gave you like one big monolithic block of Hadoop, right? Bam, right? Well, that's not the case, of course. Hadoop is comprised of lots of things. Most people, I think, these days are aware of sort of the problems in scaling the name node, right? Spotify stopped using Hadoop. They went to Google Cloud because they decided that the 300 million block size limit in the name node was not something they wanted to deal with, right? They just abandoned the whole project, which is one tactic, right? That's completely viable. We haven't taken that tactic, so we've got a whole team who's spending, all kinds of engineering effort to make our name node scale, because we're well above 300 million blocks now. And so there's that. There's, Yarn can occasionally disappear. Our cluster is Kerberized, right? So you have KDCs that could just vanish into smoke. What else? We have gateway servers, right? So our jobs are being orchestrated by a scheduler that you can find more out about later. And those things are running on hardware, right? And sometimes the existing stuff that we're doing today in wide production isn't highly available. It's just running on a single node. If that node goes away, well, all hands on deck. Let's fix this problem. And so that's another way that things can go poof. So there's lots and lots of ways that these problems can die. Additionally, we don't always produce data that stops in our systems, right? And so the client who's asking about the data might be a client of another team, right? But because we're always the data people, they're like, oh, well, that data's late, so we'll just contact those guys, and they can figure out all the problems for us, right? And so then we have to say, oh, no, it's not us, it's the SQL Server DBA team, because the SQL Server that we're loading into can't keep up with the input any longer for one reason or another. So there's lots and lots and lots of ways that these things can fail. And right, so I just summarized that. We basically got fed up with the stress that was put on. So at the time, we were maybe about 15 engineers, 5 or 6 of whom were on on-call duty, right? And so these 5 or 6 engineers were getting really, really fed up, stressed. It was an unpleasant situation for a lot of them to be continually being an integral part of the escalation process, as opposed to being called because they can fix a problem in front of them. They were routing, debugging and routing engineers, right? So, it's a true story. I was going on vacation 3 years ago, I think. 2 years ago, I can't recall it. 2 or 3 years ago. This is early summer, midsummer, and I was going on vacation, and I drew this thing on like a piece of paper that I'm going to show you in a second. And I drew it, and I said, you know what? We need to be able to visualize the dependencies at a macro level of our system, right? And then we can show that our component is in the middle of this thing, and maybe our component is operating just fine, and the problem is elsewhere, right? Or maybe our component's no longer operating fine, but we can, by creating a DAG effectively, right, some sort of dependency graph, we can actually make it obvious to the escalation engineer who's on call where the fault lies, even if there's not an alert specifically on a system, right? So this is sort of the beginning of Guerilla SLAs. And so that looks like this. This is the visualization of that. This is actually the initial board that we released, and this is, well, the latest version of the initial board that we released, and it gives you an idea of what's going on. So the team BDP, so the billing data pipeline, that team is responsible for these 2 pieces of the puzzle, right? This is provided by the Rivers team. These are the raw input to the cluster. Implicit behind that is that if this is read, then if this flaps, then it might be a Kafka problem, it might be a Hadoop problem, but we don't know, we don't care, right? We're just telling the escalation team that it's not our problem. Right? And then this over here are imports into SQL Server, and which is relatively fragile. And so when this stuff is read, we're explicitly saying it's not our problem, it's a DBA problem. And all of this might be triggered by this box being read or this box being read. And we're good citizens. We put alerts on these things, right? So we have on-call alerts to go out, notify the central escalation team, notify us. We wake up if we need to, right? But if this is read, but not necessarily read from the centralized reporting system, that just means that the engineering teams in charge of those components hadn't put enough alerting on their system, right? But so it's kind of like a passive-aggressive way to get them to put better alerts on their system. Because we can't do anything, right? So that's the fundamental thing that we're trying to display. We're not trying to say the quality of your service is shitty. We're trying to say that we can't, the person who's responsible for the stuff in the middle can't resolve the problem. So it's not worth calling them. It's worth calling these people. So what is SLAB? So SLAB is, so going back here, right? So these are boxes. The four different columns are part of the layout, and the board is an aggregation of all that stuff. And in fact, what you can't see here, I'll show it to you in a second, is that inside each one of these boxes is a set of checks. So a box aggregates checks. A check, an individual check, is going to compute a value via some sort of function that you'll implement. And then it provides a way to evaluate the output of that function. And the framework binds that all together for you. A board is then just a bunch of boxes with a layout and the dependency declarations. So there's nothing magic here. Like, we're not like, this isn't some sort of implicitly derived graph of dependencies. This is quite literally an engineer, these people saying, okay, well, revenue TAC, this box depends on these two things. And so they're going to declare that in Scala code, which I'll show you in a second. So yeah. So an example is worth 1,000 words. So let everybody know, this is an engineering manager in front of you who's going to start some coding. So sort of, all right? So bear with me. I'm going to get out of this. All righty. So is that reasonably large for everybody? Okay. So I've got some helper functions down here. Guillaume, don't look too closely at me abusing lol HTTP client, please. But basically, so this is a job check. I'm not going to go too much into the details of the check itself. But basically, what I'm doing is I'm just computing a long, which is going to be the latency of the components that we're going to look at. We're referencing an endpoint, which is the scheduler for a pipeline, the pipeline that I just showed you. And we're calling its last run endpoint. So it sort of gives us the last batch of time for which we have a complete set of data. And then I'm just doing some math on that. And then, so this is the check. So it's sort of like a side-affecting check, if you will. And then this is evaluating the check and returning either an error or a success based on it meeting a defined threshold. So this is all done in a job check function. This is not, the SLAB API provides you with the check class, but it doesn't provide you, obviously, with these functions. You have to write them yourself. And so that's sort of the idea behind a lot of what we do, is we like to give people sort of the bare tools, and then we let you kind of figure out the problem, right, to yourself, which is sort of a controversial thing here at Criteo, because a lot of people sort of like to have a lot of things, configuration based, and our team is sort of code based as opposed to configuration based. So how are we going to do this? So let me show you a working. Let me just show you the job scheduler that we're talking about, because you might ask yourself, well, why don't you just expose this all in the job scheduler that already has a graph, right? So we have this job scheduler thing. This is in fact the running job scheduler, and we see that currently nothing is executing. We have a calendar of executions, and we can zoom in and we can see that for this hour, all this stuff, all these jobs have been successful, and that there's a few things that need to be done. That appears to be housekeeping stuff, so we don't care, right? So already you get here and you're like, well, I don't really understand what the state of my system is. It's not terribly useful. Maybe I can go look at a graph. So here's all these jobs. I'm going to go click on the graph, and that's not terribly useful either, right? That's a thing. That's information, but it's not actionable by somebody who doesn't intimately know this tool and how it's to be used. And where the critical, is this the critical thing here? Zoom. Is this billing data pipeline, OX data summary import? Is that critical? I don't know, right? Only the owner of the pipeline can really know that. And so the idea behind SLAB was that this. Don't worry about the red. So was that these things here would aggregate those certain sets of related nodes in those in the graph that I just showed you, right? And make that obvious to people. So without further ado, here we go. Okay, so the first thing we need to do is we need to construct these boxes, right? Well, we need to construct the checks, but the checks I've already sort of coded the logic for those checks, where I'm just polling this endpoint for Langoustine, which gives us this result here, which I have handily, right? So we call this a last run, and we know for which the latest interval is complete. So this is, if my recollection of this API is correct, this is the last absolute time, so the latest interval for which we have, latest hour for which we have for which we have data, and this is the last period of time for which we have a complete contiguous interval of time, right? So why is that important? In our worlds, with time series scheduling, which we'll talk about more later in a different session, because things are time series, we can compute batches of data in parallel. And the minute you're parallel, you can't predict when things are going to arrive, right? And so you could have a race condition that you want to avoid. And this thing tells you, the last complete time tells you for which period of time you have a contiguous set of data. So this is the safe value, right? We want to look at this piece of data to decide if we're actually up to date, right? This just tells us, not much actually. So going back. Right, so that's what I'm pulling here, and you can see that somewhere, right, so I'm pulling out of the JSON object, I'm pulling the last complete time. So look, it's true. All right. No more screwing around. So now we're going to create some boxes. So thanks to IntelliJ, let's go take a look at the definition of a box. So the box takes a type to figure out sort of what we're, back in the origin story of SLAB, we didn't have these sort of type classes. We had just a box, and everything was sort of expected to return the same thing. But then we decided to serialize data, and it got really complicated. So sort of ignore the complexities of the API. Bear with me. So we need a title that'll go part of the display. We need a set of checks, right? We're going to have to run some checks. And we're going to have to figure out a way to aggregate those checks to determine what sort of view we actually want to produce from those checks, right? So we might have 4 checks that we run against 4 different endpoints to aggregate into a box. And we might decide that we only care about one of those, or we might care about all of them. And so we provide a way to aggregate that into a specific view of that box. You can add a description and a limit, but we're just going to stick with the basics. So title, okay, so I have my cheat sheet here, so don't. So we are going to check clicks, for example. We'll start off with clicks, and then we have checks equals, so job check. Okay, so now I'm going to go ahead and delegate to my little helper function, and in this case, consider this sort of the magic rabbit in your math classes, right? Like, it just works. And 2. So the 2 here is just indicating that it's going to be a 2-hour threshold, and that we're checking for this endpoint in the cluster in the job scheduler. So this endpoint is exposing the last runtime for the last available data for our click log for the US platform on HDFS. So if you want to, so that's the detail there. And now we need to provide an aggregation function. So aggregate. Yes, I was going to do that, Guillaume. That's true. Guillaume already pointed out the, and then so we have the take most critical function as well, which is just going to go through all of the results and take the one that is that has the. It's going to base it based on which one has the worst status, and it'll display that status to aggregate that up. And as Guillaume said, this needs to be a list. So for right now, I'm just going to get that to compile by having one check. So for those who don't know Scala, this is a way to just sort of express a linked list, and this just tells us that we're at the end of the list. If people don't like that, we can just do it in a more obvious way, and let's just do a sequence. And it should compile. All right, so that compiles. So we're happy. All right, so that's given us a box. Let's go ahead and create a second box. So let's create a dependency. So let's do that. So we're going to create a second box. Oops, whoops, sorry. I'm going to call that clicks. Okay, we'll be explicit. Click box. How's that? And then we need to, right, so if we look back at my slide, right? So fundamentally, we're sort of recreating this guy here, right? And so what we want to do is we want to get this revenue TAC thing to be exposed, because that's the critical node. You don't really care about that, but let's call that. So we're going to create the rev TAC box. By the way, rev TAC means revenue excluding total acquisition cost. It's an ad tech term. So we create a box. We are going to give it a title, and we're going to call it rev TAC. We are going to create our checks. We will start with a sequence this time, just so IntelliJ stops complaining quite so much. We'll add the take most critical long. Okay, so now it's happy, and then we're going to do a job check. And what is it called? Billing data pipeline. Oops. And we'll do, let's be explicit here, error hours, and we'll say 2 as well. Actually, let's be generous to start off with. Let's say 3 hours for the underlying data, and then 4 hours for the data we're producing. Let's make sure this thing is green before we do anything else. Let's leave it there. Let's create a layout. So the layout class, we can go take a look at that definition. So this is relatively easy, right? We have a title. We have a percentage, which is just sort of the width of the screen that we want to take. So this is literally like layout, right? And then we have boxes. We also have rows. So a layout is made up of column and rows if we'd like. But we're just going to do single. We'll do a single rows. So we need 2 columns because we have us and them, right? So it's our responsibility, their responsibility. What are we going to call the layout? All right, so column. So let's bring in columns here, and we're going to have 50% to start off with, and then right mean row. And so for the first one over there, we're going to do not our fault. And then that's going to be 100%. And then we'll have a sequence again. So you can have obviously multiple boxes per row. And so this one, we're going to put the click box in here because we only have one. That's not our responsibility. And then here we're going to put the rev tech box. And then we're going to say call us. Is that right? Compiles, is it right? Yes, that's right. Okay. Now we need a board, actually. So now we have a layout, we have some boxes, but we haven't actually stitched anything together, right? So let's stitch, the board will do the stitching. We'll get a board here. Oh, I think we need to make this lazy because I think there's a state thing that we need to do. So let me do that there. All right, board. So the board, title, boxes, aggregation, layout, and links. So links are the dependencies declared between the boxes. So the interesting thing here is that this here aggregates this. So you can decide how you want to elevate the statuses in the boxes up into a banner, right? So as a sort of a call out, you might decide that, for example, something's not consequential, right? It might be red, but you don't care about it, so you want to filter that one out. That's the idea. So let's go write that. Right. So wait a second. Let's go look at the definition again. Right. Title boxes. So title equals our data pipeline. Right, and then boxes. So this is sort of an unfortunate duplication of code that's required in this. So rev tech box, and then all right. Yeah, the aggregate syntax is really pretty awful. So whoops. So if you followed Neville's talk, you'll be just fine reading that. I'll explain it to you in a second. And then we have I didn't take the notes, god damn it, layout and then links, right. So layout equals our layout. And then we're going to create links here. And now the links are a sequence of sort of tuple declarations. So we could do this in a couple of different ways, but the arrow syntax makes it kind of nice. So we're going to say that the click box comes before the rev tech box. If I did everything right, why doesn't that compile? I have a type problem. Oh, right. Sorry. Yeah. So this is, we use shapeless. So there we go. All right. So consider that another magic word. So we use shapeless because we want to create a sequence of mixed types without losing the types. But it's complexity you shouldn't care about. Okay, so now we have everything we need. We have a board, we have a layout, we have boxes, and everything compiles, so everything should work, right? This is Scala. We do need to go into our launcher, and I need to uncomment this little thing. So there's a board and a server. So this thing is a board, right? And it's served by a server. And so all I'm doing here is I'm attaching it to the server. This is some boilerplate code that is usable. Let's kill that and then rerun. Okay, so now we have our data pipeline board. And does it work? Yes, it works. That's amazing. Okay, so oh yeah, that doesn't really work very well. So we've created our two links. What you see is though I'm only aggregating a couple different things. So there's only one, or I'm not really aggregating much. I'm aggregating one thing here, and you can see that's got the underlying latency that's surfacing is that we're only an hour behind wall clock. So that's exciting, and we can see that our actual our pipeline itself is 1 hour behind that. And based on the SLAs that we've declared, everything is hunky-dory, but we could change that if we wanted. So for example, we could just go in here and our PM has said that, no, you guys need to have 2 hour latency. And so we need to have a 1 hour latency. And so now we reload, and then everything's gonna be red. This is just a little tool we have called devloop. Wait a second. Oh, my check is. No. Yeah, let's change that. So this is a little tool we have to sort of facilitate web app engineering that you can orchestrate your build cycle with different like packaging steps and all that good stuff. So there we go. So now it's red, and we can now go talk to our data provider and say, hey, RPM is no longer happy with the 2 hour SLA you had before. We need a 1 hour SLA, and so let's have that conversation. So that's how that works. This is available on GitHub. We can it's here. You can check the code out. You can play around with it. The purpose of showing you guys the code level stuff isn't necessarily to say go use this project. This was more to show you guys how we tried to tackle what we thought was a cultural problem at Criteo in terms of SLAs on data by providing some software that enabled us to create a shared view of the state of the underlying data systems. And this works, you can use it. As you can see, the API is not the most user-friendly in the world. We accept pull requests, of course. But the fundamental thing here was using what initially and certainly was fairly trivial software to change the culture in the company. And this is the internal repository for it, and you can see these are all individual boards, and you can see there's actually quite a few of these boards that are up and running today at Criteo, where people are exposing to their clients, to their stakeholders, the state of their underlying systems. And in fact, I had one. Here's one. So here's actually a live board in production for a tool called integration monitoring. I don't even know exactly what this thing does, right? This is just some team that decided to use the software to expose the state of their system to their clients, right? So you can see that they're doing some Hive data computation or transformations. They're computing some sort of alerts. They've got a data collect thing. Who knows what that's doing? And then they're exporting it to Vertica. So you might think that, well, maybe if the Vertica boxes are red, they're going to call us since we own Vertica, right? So that'll be our fault, maybe. And this is a way that they can talk to their PM and say, look, no, the stuff is, we agreed to these SLAs. Here are the SLAs of the system, and we can all agree where the problem lies and who needs to fix it. You can see that we historize, we store the past. It's loading. So you can see that we keep track of the snapshots of all the different outages and state changes, and you can look back in time and see what was failing. And you can see that at earlier in the day around 4 a.m. The EU last advertiser event computation was 36 hours late, 24 hours late. Looks like, since the 12 hours is the other latency, so it looks like it's 24 hours late. And so that can create an actionable item. I have no idea what the context is of that, right? This isn't my pipeline. I have no idea what's underlying that, and that's the entire point, right? It's not that I'm not responsible for this. The PM knows what that is, right? The PO knows what that is. The dev lead knows what that is, and escalation knows what that is. And that's the shared view. So
your paging system now linked to this?
This actually, originally, this was actually triggering pages via alerts in Centrion. We've changed. We're using Prometheus, and I haven't actually followed the details of that. But yeah, this is part and party to the alerting system for some teams.
So what I mean is that if it's not your fault that you're not getting a page now, or are you still getting pages?
Yeah, we'll still get pages, right? We haven't gotten to the point where we actually tried to put pages onto other teams yet, right? I mean, we have that. But what we do is if we get paged enough, and we can show that it's some sort of underlying problem that we're not responsible for. Escalation is in the loop, right? We have a central escalation team. They see that, and they're like witness to that, and they can force that team to put better alerting in place for their components. So it's sort of like a conversation item, right? It's like trivial code that enabled us to change the culture around SLAs. So code got a little complex as we kept deciding to add features to it. The original API, if you'd seen it, would have been much more digestible. That's pretty much all I have. I don't know how we're doing on time, actually. I think we're late. Okay, so I'll stop talking. If anybody has any questions on this, please feel free to grab me. The project is available on GitHub. You can look at the Criteo GitHub. It's called SLAB. And thanks for listening to me spiel and code badly.